TML, meta language, it serves several purposes. First, it is a very powerful execution engine for logical tasks. It is, in many senses, equivalent to relational algebra. Relational algebra is the famous SQL, virtually all relational databases work with. It is not SQL, but there is a deep connection. But it implements relational algebra in a compressed way, and this kind of representation allows it to be a powerful logical solver by its own. And the technologies from TML will indeed be used across all our logical tools. Further, TML is also, and this gives it its name, meta language, is intended to be a compiler-compiler, a tool to write translators from one language to another. So it contains a very powerful parser, maybe the best parser that exists on the market, and tools that allow you to take the parsed tree and manipulate it, and by that create translators. So, to sum up, TML means three things: a certain kind of database, of compressed database, that in certain tasks it is orders of magnitudes faster than other databases. Second is a powerful execution engine, which also incorporates proof of execution, I will explain it, and language for writing translators. Now, for proof of execution, that's something that we work on. If you give me a program, you ask me to run the program, let's say the program returns yes or no, let's say. So I come back to you, I tell you the program returned yes. How do you know I didn't make it up? How do you know I really ran the program? In an absolute sense, there is no way to convince except something that is equivalent for you running the program yourself again. But then what's the point? You just run it without giving it to me. Turns out that under cryptographic assumptions, I can give you a cryptographic proof that the running was correct. Cryptographic means it's not a logical proof, but it is very hard to fake. So why don't you see it everywhere? Why you cannot right now give program to other people and get cryptographic certificate? Well, because it requires to convert the program into a very specific form, and that's a big headache. And in TML, because it is converted to the binary decision diagram form, already in the form that suits this kind of algorithm. So for TML program, you are able to give a short certificate. And this gives rise to important blockchain feature. Existing blockchain networks with smart contracts, all nodes in the network need to run the smart contracts as part of the block verification process. So the computational capacity of the whole network is as of one home computer, and all the work is repeated. Why not one node runs the contracts and supplies proof to the other nodes that this is the correct answer? And that's indeed yet another aspect of Tau, the proof of execution of contracts or other things in general.
And so the Tau meta language is what enables this distribution of not just computation, but also the proofs. And that relates to the logic and the trust. Professor Franconi, earlier you mentioned, how do you trust? How do you arrive at that place where there's agreement? And that's a bit of what Ohad is mentioning. What is your take or reaction to some of those solutions that you guys have come up with the Tau meta language?
If I can go back with other examples, Ohad mentioned SQL and TML. Assembling SQL is very powerful data structures, etc. SQL, database technology, is basically making a business of 17% of all IT. So 70% of all IT money goes to relational database technology. That's what companies do. That's what is really needed. Banks use SQL technologies, and banks don't want their technology to fail. They want their systems to always tell the truth about how much money do they have, how much money do they have to give to other people, and transactions have to be trusted. Now, SQL is based on logic. So SQL technology is logic. It's first of all logic. When it was created in the early 70s, it was created as a formal system. And SQL is a language where you can actually access the data and update the data and manage the data. And it's all based on the notion that the answer is always to any query or the impact of any update to the data is always trustable because there are formal proofs, mathematical proofs that tells you that. That's one aspect. And well, I have this joke that I always make. Even Microsoft, this is a joke that is good for people of my age, when Microsoft was just a nightmare, right? With Windows crashing all the time, et cetera, et cetera. The question is, how comes that Microsoft has a reliable SQL relational engine? This is SQL Server, which is very popular still nowadays. It always gets the correct answer. So it never fails. Why is that? Because, well, Microsoft have to implement their own SQL Server engine by following the logical rules, and they could not do anything else. So that's why. Another example joke that involves Microsoft is, would you trust an airplane which is run by Windows? Would you ever fly on that airplane? Well, probably not. But you do fly on airplanes. Why? Because the software in airplanes has not been by Tau, but still there is a major technology which uses logic to verify the correctness of programs in complex systems, in safety critical systems like railways, airplanes and stuff. So you can transform your program in some logical form, your software in some logical form, and then you ask to your improvers questions something like, it will ever be possible that sometimes in the future there will be a configuration of flaps, engines, air conditioning, whatever, failing batteries and stuff, so that at some point this airplane will fall down because of the software. Of course, you want the answer to be no, but you want to trust this answer. You want to ask this question, and you want to trust the answer by the system that tries to answer this question. And these systems are based on logic. They do logic-based software verification, which is a very small part. We also do this. This is somehow similar to the idea of proof that was said by Ohad before, but it's very limited to that particular context. Well, the notion of trust is what logic gives you for free. Why logic is that? I would claim that logic is the only thing that gives you that. And another example, that when we communicate and we start to argue about something, we may argue as much as you wish, but there are some things that I may say that you can never counter-argue, right? There is no way that you cannot trust what I say because I'm following a logical argumentation. I'm following some patterns of reasoning which are necessarily correct. And then, of course, there are ways they can fool you. So I can build an argumentation that is not really correct in terms of logical steps, but you don't fully understand it because I confuse you with words, etc. So you believe that the argumentation is correct. And the point is, logic is exactly the study on which kind of reasoning paths are correct and which not. So once you have done this study, you can build the ideal discussant in any discussion, or you can build a logical theorem prover, a logical system that guarantees that whatever thing you ask them, it's correct and you cannot really disagree with it. So that's the notion why this is grounded on logic.